everyone, welcome to this talk titled Unleash the Power of Your GPUs with Tron AI, presented by our guest speaker, Gijsbert Janssen van Doorn. Gijsbert is the Director of Technical Product Marketing at Tron AI. In this role, he's responsible for exciting audiences about the potential of Tron AI, acting as an advocate for the technology that will shape the future of how organizations run AI. Gijsbert comes from a technical engineering background. Prior to Run AI, he worked 6 years at Zerto, a cloud data management and protection vendor, where he held multiple roles, from systems engineering to director of technical marketing. Gijsbert describes himself as a passionate technologist whose professional motto is never stop learning and never stop having fun. My name is Juan Carrillo. I am a volunteer at TMLS. And just before we begin, if you have any questions, please ask them in the chat with a Q in front so that we can identify them. And without further ado, Gijsbert, please take it away.
Thank you so much for the wonderful introduction, Juan. Today, I'll be talking about how you can unleash the power of your GPUs using Run AI. Run AI's platform will help you effectively use all the GPUs in your environment so that you, as a data scientist, can get the power you need. Now, before we begin, a little bit about myself. So my name is Gijsbert Janssen van Doorn. I'm the Director of Technical Product Marketing at Run AI. I have a little over 20 years experience in the IT infrastructure, and I'm based in the Netherlands. So the pink little dot you see in this tiny little country called the Netherlands is Arnhem. That's where I live. That's where I sit right now. Now, let's start with a quick introduction. Let's talk a little bit about how AI has changed the computation era, or at least created a new era for computation, because we really moved from traditional software engineering to data science. And when we look at data science, there's three different stages that data science lives in. One of them is the interactive development. It's the building of the models. It's the coding. It's interactive sessions. Then, as soon as we've built the model, it goes into training. Really the experimentation phase. And this is the phase where it requires a lot of compute power. And as soon as that is done, the models are trained, we're taking them into production, or model serving, or inference, as we call it as well. And what this has done is it really changed the way we look at compute, and it introduced new types of resources, GPUs. So as companies invested in their AI initiatives and basically purchased those GPUs, data scientists started to use those. Talked about all the different stages within AI, talking about train, build, and actually all the way up to serving models. And in AI, new types of compute resources are needed, specifically GPUs. And those GPUs are quite an investment for organizations. And a lot of organizations started investing into GPUs to support the data science movement, to support the AI initiatives. But what we found, and we did a survey recently, what we found is that 80% of the companies that helped us out with this survey underutilized our GPUs. So that means they're not taking all the benefits that they can get from the GPUs. They're not taking the power that they can get from the GPUs. And there's a reason why that happens. That's because data scientists consume compute power in a completely different way. They might use massive amounts of GPU power for days and then sit idle for weeks. And that's because of the nature. That's because there's a different pattern than more traditional software engineering workloads. We could be training a model for a couple of days and then work on building a model, developing a model, coding it without actually consuming GPU resources. Now, one of actually the graphs you can see on the screen right now really illustrate that. 6 different users, 6 different patterns, 6 different ways of allocating and using GPUs. And there's a reason why that happens and why it's so challenging to get to a great utilization of GPUs. And that's because the data science workflows and the hardware accelerators, or GPUs, are highly coupled. That means there's a static allocation. Most of the times, data scientists or teams of data scientists get assigned a static number of GPUs. And actually, the GPUs in the background, the actual hardware, are static as well. So that means if they're not using the GPUs, they're not being used. They can't be taken by another team. Now, that results in slow research that really limits the workflows, but also results in underutilized GPUs. Now, RunAI's vision is to fully abstract those hardware accelerators, fully abstract those compute resources, and have the data scientist simply use whatever is available in an environment. Really making sure that data scientists don't need to worry about resources anymore, and they can just do the work they need to do and get the resources whenever they need to. And that's exactly what RunAI does. Because RunAI offers centralized compute management for the AI era. Basically, we match any AI workload to the right amount of compute power when it's needed. So let's take a little deeper look at the RunAI platform. So where does it live within the AI infrastructure stack? RunAI sits between the infrastructure resources, the compute resources. That could be GPUs, compute, RAM. It could be on-premises or somewhere in the cloud. So we're completely agnostic. And sitting on top of those hardware resources allows us to control those. And what RunAI does, it basically allows data scientists to execute jobs, and they can do that however the way they want. They can use our CLI, our command line. They can use an API. They can use YAML files, or they can use the tools that they're used to, the MLOps tools. They can use Jupyter notebooks and simply execute whatever they want on the platform. And RunAI, using fair share scheduling and distributed training, give you the resources whenever you need them. We have built-in preempting. We can allow you to predefine policies and set priorities to make sure that whenever someone launches, let's say, an interactive session to develop a model, that gets a priority over a training that's running. So we can preempt that and make sure that the training will continue as soon as the resources are available. So this really sophisticated fair share scheduling makes sure that you can get the resources that you require to have whenever you need them. We even allow data scientists to get more resources than they have been assigned as soon as they are available. So we're really abstracting all of those compute resources and making sure that they're available whenever you need to. Now, we also offer visibility, giving insights into how workloads are performing right now, how much utilization do they, how much resources do they consume right now. And this gives you insights and analytics to predict what you need in the future. And we support all the different types of workloads. We support build, we support train, we support taking them into production, the inference workloads. And again, having this open nature of our platform, you can use the tools that you want. You can build Kubeflow pipelines. You can open up Jupyter notebooks. We have integration with Apache Airflow and many, many more. So really giving data scientists the freedom to just do the work they need to do without ever worrying about the compute resources in the backend, because that's completely managed by RunAI. Now that sounds fantastic, of course, but I want to make sure that when looking at this, what are the results? What happens to an organization as soon as they adopt RunAI as their dynamic AI workload platform? And this is an example of what happens in an organization that has many GPUs as soon as they start using RunAI. As you can see, they onboarded RunAI and they were having about a utilization of about 25%. Out of the 40 GPUs they had available, they used on average about 10. And as you can see, the system is smart. RunAI is self-learning. The more they used the platform and the more they saw the benefits, the more they started using all the resources available. So within weeks, they went from a utilization from 25% all the way up to 100%. They were so effective that they decided to buy more compute power. As soon as that compute power was added, we started utilizing more GPU power. So really making sure that the allocation is at 100%, making sure that you unleash, like we said, that power of the GPUs. Now, this is allocation, right? How many GPUs am I using? But what is the utilization? How does this result in actually being able to do more experiments, to do faster training, to get things into production faster? Now, let's look at actually utilization. And these are the number of jobs that entered the Run AI system, again, over time. And as you can see, we went from a utilization of about, let's say, 10% all the way up to 90%. So then there were more jobs running. There was more work done, more experiments running. Less jobs that were waiting for resources because that's managed by the Run AI system. And using 20% of your GPUs over 9 weeks, we went all the way up to 80%. Having 80% utilization versus 21st is a 4x improvement, while doing more work, more important work. So that's an amazing result after using the Run AI platform. And there's a reason that data scientists love Run AI. They can offer accelerated AI development. We can improve cluster utilization. We can improve end-to-end cluster visibility and control. And this is a quote from one of our customers. They've seen great improvements. And I think this is the most important part. They went from an average experimentation time of 49 days all the way down to 2 days. So you can see why data scientists love using Run AI as their workload orchestration platform. Now, I talked and I mentioned a survey early on, and we conducted a survey back in October, and the results of that are in a report, which we call the 2021 State of AI Infrastructure Survey. I definitely recommend you downloading it. I've put the link up right here. I even added a QR code, so if you want to scan it and quickly download it, please do. It contains a lot of insights into how organizations are building their AI infrastructure right now, the challenges they run into, and that's how we got to that number of 80% as well of organizations that underutilize GPUs. So feel free to download that one. And now I'd love to open it up for questions. I added my details to a slide. Feel free to reach out to me. Feel free to follow me on Twitter or add me to your LinkedIn or reach out to me on email. And let's see if there's any questions there. Any questions at all, don't worry about it. I'll make sure I'll open them up and look at them.
Thank you, Gijsbert, for such a great talk. It's good to see those numbers and see the measured impact Run AI has had in organizations. So we had questions coming in from the audience. Let's begin with one from Emmanuel. For organizations physically that own their compute resources, do you believe maximizing GPU utilization will result in an increased hardware degradation? And if so, how will one go about balancing GPU utilization and hardware life cycles?
That's a great question. Actually, balancing GPU utilization is part of what we deliver as Run AI. It's part of our platform. We'll make sure that we'll use the resources when they are available, where they are available, and make sure that they're balanced across all the different resources. I think one of the beauty of GPUs is that even though they're physically limited by power, the frameworks that use the GPUs get more and more advanced over time. So even speeding up, even though you don't get new compute. So get more out of your GPUs. Now, the balancing is all hands off. That's basically what the Run AI platform does for you.
Thank you, Gijsbert. Another question is, in case there is a sudden demand for GPU compute, and the ones that are physically on premises are not enough, is there a way for users of Run AI to quickly get access to GPU instances in cloud services like AWS or Azure?
Absolutely. We support the hybrid approach, so we can add cloud resources to our platform and start using them. Basically, as soon as you add those resources to Run AI, we are ready to take them on and distribute them across the workloads that need them. We support all the major cloud vendors. We support AWS, we support Google, and we support Azure as well. So that's definitely something that we support and see happening. Those burst type of questions.
Okay, thank you. One more question. It's related to experimentation in edge devices, such as the NVIDIA Jetson. Is there a way for users to also manage those pieces of hardware within the Run AI platform?
Basically, any device that has a CUDA-enabled GPU and that can run, let's say, Kubernetes or containers is something we can use in the platform.
Okay, thank you. That's good to know. Maybe let's see other question. Okay. We saw evidence of utilization in companies. Have you had experiences with scientific computing, or let's put it this way, workloads that also use CPU compute, like many cores at the same time?
So yes. Now the optimization Run AI delivers from a GPU perspective is limited to GPUs. We have built-in technology, what we call a GPU abstraction layer, that allows us to split up a GPU into multiple slices and utilize those, so you can run multiple jobs on a single GPU. From a CPU perspective, we also take CPUs and memory into account when executing those workloads. There's no specific optimization from that perspective within the platform. We manage it. We make sure that those resources are available. We can balance that across the different nodes within our cluster, but there's not a need to do such a deep integration into CPUs, because that's already well done by for decades already with multiple cores and virtualization on a different perspective. But we can also manage the CPUs of jobs.
Okay, thank you very much. Thank you, Gijsbert, for such an interesting and insightful session. Thank you very much. At this point, I would like to ask the audience to join me by giving Gijsbert a round of applause, a virtual round of applause. That's the better we can do. Thank you very much for your time.
You're welcome. Thank you.
Really nice diagrams, really nice visuals. And just a quick reminder for the audience, also make sure you check the booth section for prices and swag, as well as networking and job opportunities. There's lots of really cool people to meet. So make sure you also hit the Let's Network button. That's a really nice way to get to know people in the industry. And I think that will be it. Thank you very much, Gijsbert, again.
Thanks for having me, Juan.
Everyone around.